Hello, everybody. Today we're going to be starting Chapter 8, which is all about quadrilaterals, special quadrilaterals, in fact. So you're going to need your notes, something to write with, and a calculator. And for this portion of our unit, you're going to need those shapes, cutouts that you got in class, and you're going to be taping these in your notes as we go along. So let's first start with a definition that's in your notes. This needs to get written down. When we talk about quadrilaterals, because that's what this whole unit is about, quadrilaterals, what are we talking about? What does that word mean? Basically, a quadrilateral is a shape that has four straight sides, and all the sides are connected. So we're talking about four-sided shapes. In general, they could look like a square, a rectangle, okay? Any sort of four-sided shape that has four straight sides and all the sides are connected there to enclose a shape or a region, that's what we're talking about when we talk about a quadrilateral. Now, in the quadrilateral family, there are special quadrilaterals, and that's going to be the focus of the beginning of this unit, are those special four-sided shapes that we're talking about. The first one we're going to look at today is parallelograms. We're going to be investigating what a parallelogram is and what kind of special properties he has. For this part, you're going to need to tape your parallelogram. You have an actual photocopy. Tape your parallelogram in your notes like this, and we're going to have a heading called parallelograms. And then underneath, we're going to write all the properties that parallelograms have down here. So you're going to need some space to write what parallelograms have that's special about them, and then we're going to identify those things on the shape above. Okay, so we're going to be taking basically a full page of property notes, and then we'll throw some examples on the next page. Here's what that cutout looks like that you have in your notes and you've taped them in. This is parallelogram, or we're going to assume he's a parallelogram here, A, B, C, D. So when we take a look at parallelograms, notice his four sides. And parallelograms, if he's a true parallelogram, there are certain properties that these shapes have. The first property, sorry, that they have is that opposite sides are parallel. And this is by definition. So please make sure that you write these down in your notes. The definition of parallelograms is a four-sided shape that has opposite sides parallel. So on your parallelogram picture up here, how is it that we mark when things are parallel? We use those little filled-in triangles, okay? So if I were going to mark AB parallel to the opposite side, the side opposite him would be across from him, and that would be side CD. So I would be saying that AB, that side, is parallel to CD. That's one pair of opposite sides that are parallel. But in a parallelogram, it's not just those two sides that are parallel, it's also this top side up here, and the bottom side down here will be parallel as well, because both pairs of opposite sides are parallel. So we would say BC is parallel to AD. Okay, those are two facts that we have about this parallelogram. Now there's more going on with a parallelogram than just parallel sides. Because he has these sides that are parallel, some other things happen. In fact, the second property is that opposite sides are congruent. Now remember, that means equal. So when we go to mark this on our picture, that means that I will be marking that opposite sides are in fact the same length as well. And we do that with those little slashes again. So AB and CD are congruent to each other. They are opposite sides. So I would say AB is congruent to CD. And also, AD is congruent to BC. Notice the two little slashes there? We can't use one slash because that would mean he's the same as the other two sides, and that's not the case. So BC is congruent to AD as well. So we have opposite sides that are parallel, and we have opposite sides that are congruent. The third property involves angles. So this time it says that opposite angles are congruent. So we're going to be looking at angles, the corners of this shape. Now if I was going to mark this, I'd go to my picture and choose, let's say, angle A. I'll put two slashes through angle A. The opposite angle with angle A would be across that shape from him, so that would be angle C. These two angles are congruent, so I would say angle A is congruent to angle C. But there's another pair of opposite angles. B and D are opposite as well. So angle B is congruent to angle D as well. The fourth property that parallelograms have is that consecutive angles are supplementary. Consecutive angles being supplementary. Now remember, supplementary is a key word that we should remember. That means 180 degrees. So they add together to make 180 degrees. Consecutive means not opposite. So they're not across from each other, they're in a row. So when I was going to identify these on my picture, this angle A and angle B will add together to make 180 degrees. I think I'm going to switch my arrow here. Angle A and angle B will add together to make 180 degrees. Angle A plus angle B makes 180. Okay? Whatever they are, the measures of those angles will make 180. That's one pair of consecutive angles, but there's more. B and C are also next to each other in a row here. They will also make 180 degrees together. And then C with D, 180 degrees, okay? And then A with D as well, okay? Try to draw that here in my picture without getting a little too messy there. So we're taking a look at all of those angles and how they add together to make 180 degrees. So if you want to, you can write that next to the property, or you can mark it on your picture above. And last but not least, each diagonal is bisected by the other. This is the fifth and final property of parallelograms. So diagonals are when you connect corner to corner in a shape. So the diagonal that I might draw in this shape would be from B to D. And then another diagonal would be from C to A. And maybe in the middle, I'll call this E, let's say, where they cross. Okay, what this means is when each diagonal is bisected by the other, bisected means cut in half. So that means B to D, that line right there, B to D, is cut in half by that point E there in the middle. So if I was going to put some slashes on my picture, this piece would be the same as this piece. Okay, so I would say BE is congruent to ED. But there's more. There's another diagonal that goes from A to C. Right here. Here we go. There he is. Okay, remember that diagonal? He's also cut in half. So if I was going to put slashes on that, would I put the 3 slashes on those? Nope, I'd have to use 4 because they're not the same as the other ones. B to E is a little bit shorter than it is from A to E. Okay, so I'll put 4 slashes on there, and I should say that A to E is congruent to E to C. Okay, to side or to piece EC there, because it's not really a side. So what we have going on in a parallelogram is a lot of special properties. Okay, lots of things are happening. We have parallel sides, we have some equal sides, we have some equal angles, we have some angles that add to 180, and we have diagonals inside the shape being cut in half by the other diagonal. These are all key things that we can use when we go ahead and solve for missing parts of parallelograms. So we're going to put a few examples in your notes now of where we may use these properties. This says JKLM is a parallelogram. Find the measure, it should say angle L. Okay, this one doesn't take a whole lot of work, but I would write this example in your notes. Okay, or at least draw the picture. If we wanted to find out what was happening with those angles, if we wanted to find the measure of angle L, we would use our properties to help us. The measure of angle L would equal how much? Well, this is a parallelogram. See those parallel markings? Parallelogram. And in a parallelogram, there are properties about the angles. Opposite angles are the same, and then consecutive angles will add up to 180. The only number I'm given here is 135. Check out 135 right there. He's consecutive or right next to angle L. And that means that those two angles will add up to make 180 degrees. So I can use that fact. I can take 180 minus 135. And that leaves me with 45 degrees for angle L, because these two angles right here will make 180 degrees. Okay, let's write a second example. This one has a little bit more algebra involved, okay? Make sure that you're writing this one in your notes, because a lot of our work over the next few days is going to be focused on using algebra within shapes to find x or find missing pieces, okay? Here we go. ABCD is a parallelogram. Find the value of x. So take a look at our picture over there, and I'm noticing that we have some stuff labeled in our picture. This represents angle A, and this expression represents angle C. Now, A and C are angles of this parallelogram, and from our properties, we know that the angles are either equal or they'll add up to 180. These two are opposite angles, and because they're opposite angles, they're on opposite corners of the shape here. Because they're opposite, that means that they're equal to each other or congruent. So I'll go ahead and take the 9x plus 2 and set it equal to the 12x minus 34. And now I'm using algebra to solve for x. So I need to get the x's together here on one side. So I'll have 2 equals 9x, or 12x minus 9x is 3x's, minus 34 still. Then I'll add the 34 to try to isolate the x. I have 3x equals 36, and then I'll divide by 3. X is 12. So according to the way that picture is drawn and our properties of parallelograms, the x would equal 12. Okay, and our third example and last example. This one's pretty complicated. So take a minute here and draw this one in your notes. Looks like we're going to be solving for x and y in this picture. Oops, sorry. Here we go. Solving for x and y in this picture. Again, a parallelogram, you can see the parallel sides. We have diagonals in there. Oh my, we have a lot going on. Okay, lots of things are happening inside that picture. Okay, so what do we know? Well, we know we need to solve for x and y. Here's something about x, and that looks like it's pointing to this big angle here, angle G. Okay, that old angle. If I look next to angle G, angle F over here has one little slash through it, and this 50 is supposed to be for that whole angle F, okay? Now, angle F and angle G have a special relationship. Those two angles will add up to make 180 because they're consecutive, okay? They're not across from each other, they're right next to each other or in a row. So what I would do to solve for x is I would take my 50-degree angle, which is angle F, plus angle G here is going to make 180 degrees. So the measure of angle F is 50. The measure of angle G is marked with 7x plus 4. And then I know it's going to make 180 degrees when I add them together. So 50 degrees, these are all in degrees here. So basically on this side, I have 7x plus 54 equals 180 degrees. And then I'll go ahead and subtract the 54. 7x equals 180 minus 54. That is 126. And then I'll divide by 7 to isolate my x, and x equals 18 degrees. So we've solved for x. Now let's go ahead and solve for y. Y is located here on our shape. That is marking a side, F to G right here. This whole side is 6y minus 9. Now if I look around the shape up here, I notice that E to D is marked with 21. They are opposite sides, and in a parallelogram, the opposite sides are congruent. So that means my 6y minus 9 side will have to equal the 21 side. So now I can go ahead and solve that by adding 9, 6y equals 30, and then y equals 5 when I divide by 6. Notice I didn't mark degrees on that one because I wasn't finding an angle here, just a length, okay? So x and y solve for based on the properties of parallelograms. Thank you for taking good notes today.